Tonight you are doing 5-3. This is 5-3. And you don't need to write this at first. This is the elimination or addition method. You're using the big ideas. You are doing page 251, number 1 through 33 odd, and number 34. All right. So the first thing we're going to look at, we've got a couple different methods on how to solve a system of equations. The first is the graphing method. Don't like this. Not at all. It's my least favorite for 2 reasons. Well, the PowerPoint says it's time-consuming and it's not always accurate. It's not efficient. We can't get an exact number all the time. So then we yesterday learned about the substitution method. Substitution is a good method when applied in certain situations, if my variables are alone. Tonight we'll be learning the elimination method, or sometimes it's called the addition method. So this is when I line my equations up, if they're in the same form, whether it be slope, intercept, or standard, and we add the equations vertically. So A plus C is equal to B plus D. Okay? So let's see what that looks like. If I take my 2 equations and I add them vertically, look what happens. I draw a line. What's 2x plus 5x? Yep. Sorry, 2x plus 3x. And what happens plus y and minus y? Josh? What? They cancel. We call those an additive inverse. Everybody say additive inverse. Adding the opposite and they make 0. They cancel each other out. And then 6 plus 4? 10. So we add vertically and we get 2x plus 3x is 5. My y's are eliminated, hence the elimination process method. And 6 plus 4 is 10. I solve for x, divide both sides by 5, and x equals 2. Now I go back to either original equation, and notice I'm going to draw the arrow because that leads the reader. To show them, I'm going to substitute here. So I get 2 times 2 plus y equals 6. 4 plus y equals 6. Subtract 4, and y equals 2. So, Billy, what would the solution be? 2, 2. Questions? Yes?
When you're doing this method, if it's in slope intercept, does the y not meet, can it have a coefficient in the y or not?
Okay, yes, that wouldn't be slope intercept, but we'll talk about that in a minute. Okay, let's continue. Thumbs up if I can keep going. Okay, so we can always check our solution. I substitute 2, 2. Okay, I'm substituting in mentally. 2 times 2 plus 2, does that equal 6? Yep, and 3 times 2 minus 2, does that equal 4? Yeah, so it works. The good thing is there's always a quick check there. All right, let's try one. Now, you guys are doing this one on your own. We're writing x plus 3y equals 5 and negative x plus y equals 3. And you guys are doing this one on your own. Pause the recording. All right, so step 1, what am I doing, Griffin?
Step 1, you're going to cancel out x and negative.
And notice I put a nice line there. I don't like block it out so I can't see it. I just put a slash through it. And what do I end up with?
4y equals 8.
4y equals 8. And then we divide both sides by 4, and y is equal to 2. Next step, Sophie.
You would
or either equation. It could be either original equation. I'm substituting it in. Okay. X plus 3 times 2 equals 5. X plus 6 equals 5. Subtract 6. And we are left with x equals -1. And the solution should have been -1, 2. Questions? All right. Moving on. Now, in this situation, we cannot just start eliminating. Remember I said they have to be in the same basic form. Your x and y have to be on the same side, so I cannot just start lining the y's up. So what would I need to do? Sophie.
The first equation, you have to subtract 3x.
Good. So we're taking the first one, subtracting 3x. Now notice, I'm showing the new equation to the right, not underneath, because when I show things underneath, it implies steps. And like this is step 1, step 2, step 3. So I'm not putting the new equation underneath. I'm showing an arrow and putting it to the right. So what are you going to do? When you subtract 3x, and we end up with?
Y minus 3x.
No, line it up the way the other equation is written.
Oh, -3x plus y equals 4.
Good. -3x plus y equals 4. Okay? And then I'm going to line the other one up. Notice I put an arrow. Now I can do my elimination method. Okay? We're subtracting, and we end up with, Ben?
You would end up with, the lines would cancel out each other, and then it would be, -1, negative x equals 9, and then it would be, x equals -9.
Perfect. Multiplying both sides by -1. And then what am I going to do, Liam?
Then you have to plug 9 back into the original equation.
Into the original equation. Either original. Okay.
So you use that one. Then you just plug in 9 for x. And so then you get
Y.
y equals -27 plus 4.
And that equals, when we simplify,
You get y equals -23.
okay, and so my solutions are -9, comma, -23. Questions? Yes?
Will it ever be where the number is getting, crossed off, or it's always the variable?
We're trying to eliminate a variable. So we will always try and manipulate a variable. Yes?
What happens if one of the equations is missing a variable?
Then I wouldn't use this method. Okay. So now, what are we going to do? The question was, what happens if one of the equations was missing a variable? I wouldn't use this method. I would use substitution. Okay? Yes? Yeah, this time we have to do some manipulation. We need to manipulate so one of them becomes an additive inverse. And so there's nothing that already can cancel each other out. So we have to multiply by a number that will allow me to cancel out. So what did you say? Good, because what is the opposite of 2x? So what would I need to multiply this by to make that a -2x? By -2. But I can't just multiply one, I have to multiply all parts. So notice, they're showing you what happens when we do this. Nothing eliminates. So we're going to multiply everything First equation stays the same. Second equation becomes negative 2x minus 8y plus 8y minus 18. Now, my additive inverses cross cancel. Aiden.
It's 11y equals negative 14.
22. And that's looking nice and pretty. Okay, divide both sides by 11, and y equals negative 2. Okay, now we are substituting in. And I substitute in, and I get x plus 8 equals 9. X equals 1. And remember, never are you guessing where my eyes are supposed to go when I'm reading your work when you see these arrows. So show me where to go. Show my eyes where to go. It's a silent conversation. For this year, it's between me and you. For next year, it's between you and Chidas. And for the year after that, who knows who it's going to be between. Okay, and so my solution is 1, negative 2. Questions? All right, solving using the elimination process. So here we go. Now, in this case, what are we going to do to eliminate? Actually, why don't I leave this to you guys, put it on pause, and you guys try and solve this. Let's check our work. What did you do?
I just did equation. I did 2x plus 5y equals 10 over 10x minus 5y equals 35.
Good, so you are multiplying the bottom equation by 5. The new equation becomes 10x minus
5y equals 35.
perfect.
Then I got 12x equals 45.
12x equals 45.
Now divided by 12 and x
Shh.
equals 3.75.
Good. 3.75 or 15 fourths.
I plug it into 2x minus y equals 7.
Shh.
So I got 7.5 minus y equals 7. Subtracted 7.5 from both sides. And I got y equals negative 0.5. And I multiplied everything by negative 1. And I got y equals 0.5.
And my solution was 3.75, comma, 1/2. Now, some people, so if we go back, and did you get the same answer? Yeah. So what some people are saying is they multiplied everything by negative 1 at this point in the bottom equation or the top. Doesn't matter really. Doesn't really matter. They went by negative 1, and so this is 2x plus 5y equals 10, and this becomes negative 2x plus y equals negative 7, and we get 6y equals 3, divide by 6, and y equals 1/2, then substitute in 2 times x minus 1/2 equals 7. Add 1/2. You guys get it? And we get 2x equals 7.5. Divide by 2. X equals 3.75. Y is, and so then it would be 3 and 75/100, comma, 0.5. Right? So both methods work. All right. Now, worst case scenario. Oh, my goodness, did you hear that voice crack? I'm getting sick. All I do is pray that I don't get sick because I don't want to miss an algebra day because we don't have time. So I can't get sick. All right, in this situation, what do you think we're going to do? I see, Josh, what do you think? Yeah, we have to manipulate both equations because I need to get an additive inverse. We have to get an additive inverse. So we can multiply the top one by what?
Multiply it by 2.
Okay. Let's see what they're multiplying by 5.
And the bottom one by 2.
And then the bottom one by 2. Now, you could have done the other two. It doesn't matter. We're just going with what my PowerPoint happened to do. And the bottom one by 2. And where we get to, what we get to eliminate is our 10x's. Those are the additive inverses. So now I am clearing my x. I'm left with 11y equals 33. And it's working out very pretty. A nice, pretty number. Divide by 11 and y equals 3. Then I substitute. And I end up with 5x equals 6 minus 4. And x equals 2. But don't forget what we're trying to do. Now notice every time my eyes are being told which way to go. If you're not working in steps, you have to draw arrows and tell the reader. Your high school teachers will thank me. Okay? All right. I want to hit this word problem really quick. So, don't worry about it. Business with 2 locations by several large delivery vans and 5 small delivery vans. 7. Sorry. Location A receives 5 large vans and 2 small vans for a total cost of $235,000. Step 1. What are we saying? What are our unknowns? What are we calling X? Ben? Small.
And then Y.
Small van. And what are we calling Y?
Big van.
Large van. Okay? So how do I write this, Griffin? 5 large vans and 2 small vans cost $235,000. Whoops.
So it's going to be 5y plus 2x equals 235.
5 large
So 5y,
plus 2x equals what?
235,000.
Okay. Next equation, please. How about Sam?
The next equation is it would be 2y, or no,
Yeah?
2y plus 3x equals 160,000.
Can I get rid of the zeros?
Yeah.
Hell no. Oh, sorry, I'm recording. I didn't say that. Heck no. Heck no. Zippy Longstocking, Yamasaki. Okay. Okay. If you won $235,000 in the lottery, and they said, I'm going to give you 235 instead of 235,000, would you care? We're not allowed to get rid of those zeros. It's money. It matters. So we're doing the same thing. We're just manipulating each equation. In this case, I might manipulate the x's. What am I multiplying the top one by? How about 3 in the bottom? No. -2. And then we start the whole process. It actually works out very nicely. Okay, questions? All right. Now I want to try and cover this one word problem yesterday from,
We have like 2 minutes.
I know, some of these word problems. Okay, here we go. I just want to cover the writing of it. Meaning how to write it. Okay. All right. So on number 20, let's look at how to do this. A farmer plants corn and wheat because there's no reason to eliminate these. A farmer plants corn and wheat on a 180 acre farm. The farmer wants to plant 3 times as many acres of corn as wheat. So first of all, what are our unknowns? X is what? Corn. Or I could do C for corn. Shh. And, oops. And W for wheat. Shh. Okay. So, the first one, what's the equation going to be? Corn and wheat on a 180 acre farm. First equation. Yes. What? That first equation that I just underlined?
Oh, that one.
Corn and wheat equal 180 acres. C plus, stop. Stop. We're finishing this. Stop. 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 Freeze. I'll wait. C plus W equals 180. Now, look at the other equation. Shh. It says the farmer wants 3 times as much corn as wheat. So am I doing 3 corn or 3 wheat? No, the corn needs to be more. Corn needs to equal 3 times wheat. Because we want the corn to have more. And then we substitute. Does that make sense? I need you to stop avoiding the word problems. Got it?